Hi, I'm Miss Roger, and welcome back to Core Concepts in Algebra 2. Today's lesson is on sketching polynomials. The Massachusetts curriculum frameworks for mathematics are specifically tied to today's lesson. A-REI, Reasoning with Equations and Inequalities, number 7, and A-APR, Arithmetic with Polynomials and Rational Expressions, number 3. Let's take a look at today's lesson objectives. To write a polynomial function in factored form when given its zeros, to write a polynomial function in standard form when given its zeros and/or factors, to identify the end behavior of a polynomial, to identify the y-intercept of a polynomial, to identify the x-intercepts, roots, zeros of a polynomial in factored form, and to sketch a polynomial using the key features. Let's take a look at one aspect, which is determining the end behavior of a polynomial. So by inspection, end behavior can be determined by the polynomial's highest degree in the leading coefficient that goes with it. So what we're going to see is when we have the highest degree raised to an even power, the polynomial's end behavior is going to either go up, up, or down, down. And we can think about this as the left side rising, the right side rising, the left side falling, the right side falling. When we have the highest power being an odd number, we're going to notice that we have either the left side falling, the right side rising, or the left side rising and the right side falling. So we can kind of start to figure out what's going to happen based on the highest degree in the leading coefficient. If the leading coefficient is positive, and the highest power is even, this is going to be how our end behavior functions. If our highest degree is even and the leading coefficient is negative, this is the sketch of how our end behavior is going to function. If our leading coefficient is positive and our highest degree is odd, this is how our sketch is going to function. And then our last option is when our leading coefficient is negative and the highest power is odd. So we want to consider these as we progress through polynomial graphs. So let's consider the x-intercepts, the roots, and the zeros. And when we're determining these, we want to make sure that we're conscious that the x-intercepts, the zeros, and the roots all mean the same thing. So given a polynomial in factored form, we're going to use the zero product property to find values that will make the polynomial equal 0. The number of times an x-intercept is a solution to the equation f of x equals 0 is referred to as multiplicity. So we're going to use this idea when we're figuring out how to sketch this and how to use this idea of multiplicity when we're actually sketching. So if the zeros have an even multiplicity, they will touch the x-axis. If the zeros have an odd multiplicity, they will cross the x-axis. So let's take a look at an example for ourselves. If we have zeros of 1, -1, 2, and 2, and these are our zeros of the polynomial, what we're going to see happen is we're either going to touch or we're going to cross the graph, depending on the multiplicity. So when I look at 1, 1 appears once. So 1 is an odd multiplicity. So for our 0 of 1, it's going to cross the graph. For -1 also shows up once, so this is going to cross the x-axis at -1. For our 0 of 2, we have a multiplicity of 2. 2 is an even number, so at 2, it is going to touch the graph. And we're going to see what this means when we actually get to some examples. Let's take a look at our first problem. Given factored form, f of x equals x plus 3, x plus 4, and x minus 1. We want to write the polynomial in standard form. So what we're going to have to do is we're going to have to multiply the factors together in order to get a result. So let's start to do that. So the easiest way to do this is to multiply the first two binomials together, get an answer, and multiply it by our second binomial. So I'm going to FOIL these out, multiply these together first. My result is obviously a quadratic, x squared plus 7x plus 12. Now what I want to do is I want to take my quadratic and multiply it by my linear binomial. Once I multiply these together, I'm going to have standard form. So I want to do this in an organized way. I want to multiply everything in the first by everything in the second. So I'm really going to go one term at a time. X squared times x is x cubed. X squared times -1 is -1x squared. Okay, I'm done now with x squared. I'm going to move over to 7x. 7x times x is 7x squared. 7x times -1 is -7x. And I'm now all done multiplying by 7x. I'm going to move over to 12. 12 times x is 12x. And 12 times -1 is -12. So now I want to add all these up. And once I've added them up, I'm going to have standard form. So I'm going to have x cubed (6x squared) plus 5x minus 12. So my standard form polynomial, when I was given factored form, is f of x equals x cubed plus 6x squared plus 5x minus 12. Let's now determine our end behavior. So I've already written down what our standard form polynomial is when given factored form. Remember, with end behavior, you want to look at the leading coefficient with the highest degree. So this is really saying 1x cubed. And when we think about our end behavior, we want to think kind of what's happening with the left and the right portions of the graph. Since we have x cubed, this is really like saying x to the odd. Our leading coefficient is positive, so our end behavior is going to look something like this. Now let's determine our y-intercept of the polynomial. So we can do this in a couple different ways. If we connect this back to what we did when we were in the quadratics chapter, we would always have our c value as our y-intercept. So our y-intercept for this problem is going to be -12. Another way that we can do this is we can think about factored form. If we multiply 3 times 4 times -1, we're going to get that -12, which is our y-intercept. And we're going to notice that this happens for all of our polynomials. Let's now determine our x-intercepts, or our zeros, or our roots. And the way that we're going to do this is we're going to think about each factor, and we're going to use the zero product property. So I'm going to set each factor equal to 0 and solve. So x plus 3 equals 0, x plus 4 equals 0, and then our last one is x minus 1 equals 0. So when I do this, I'm going to subtract 3 from both sides and get it x equals -3. I'm going to subtract 4 from both sides and get x equals -4. And our last one, I'm going to add 1 to both sides and get x equals 1. So our zeros here are going to be -3, -4, and 1. And again, remember, typically we put these in set notation, which is our curly brackets. Let's now use all this key information to actually sketch our graph. So we have our standard form, we have our end behavior, we have our y-intercept, and we have our x-intercepts. So we can transfer all of this information and all of this understanding to our actual graph. Before we do that, we want to think about that multiplicity piece. And we want to think about when this is going to cross and when it's going to touch the x-axis, specifically for these x-intercepts. So when I think about -3, -3 is showing up once. It's only coming up once. So 1 is an odd multiplicity, so it's going to cross the x-axis at -3. For -4, again, it's showing up once, so this is going to cross. And same for 1. So all of these are going to cross the x-axis at that specific 0. So let's start to map this out. We have a y-intercept of negative 12, so why don't we plot that? We have zeros at negative 4, negative 3, and at 1. And I'm not going to build all of my sketch here and all of the tick marks. It's just a rough estimate of what's happening. So I'm just going to map this stuff out for myself. My end behavior, we're finishing up here on our right side, and we are falling on the left side. So now I've mapped everything out. So now I need to think about what's happening and literally go from left to right and think about that as I'm kind of working. So I'm going to start down here on the left, and I'm going to approach negative 4. Negative 4, it's going to cross the x-axis at negative 4. So I'm coming up, and I've crossed. My next x-intercept is negative 3. So I need to cross the x-axis again at negative 3. So I'm coming down, and I finally cross. Okay? So my next point is negative 12, which is the y-intercept. So I am going to continue on and start to come up because I need to cross again at 1. So this is going to be the sketch of my polynomial, and when you draw this, you want to make sure you have as smooth curves as possible. Let's take a look at what this is going to look like on our graphing calculator in order to confirm. So when we graph this on our graphing calculator, which is a handy tool in order to think about what this visually looks like, we see a similar picture. Let's take a look at another type of problem. Write the polynomial in factored form and standard form given the x-intercepts. So factored form is going to come first. And remember, when we write f of x or y equals, they're ultimately the same thing. So f of x is going to equal x plus 2, x minus 1, and x minus 4. And notice how I did x plus 2, and I raised this whole thing to the second power. So if you see a root of negative 2 and negative 2, notice that the multiplicity is 2. So I can write this more completely as x plus 2, and that whole thing is raised to the second power. And then we have our x minus 1 and x minus 4. And the way that I'm doing this is I'm thinking about, okay, if I set these parentheses equal to 0 using the product property rule, I can get back those x-intercepts. So now I'm going to take this and put this in a standard form. So I'm going to deal with this first. I'm going to actually multiply out x plus 2 and x plus 2, get a quadratic. And then I'm going to multiply out x minus 1 and x minus 4, get a quadratic. And take these two quadratics, put them together, and get a polynomial of degree 4. So let's do this. So when I multiply out x plus 2 and x plus 2, I'm going to get x squared plus 4x plus 4. Now I'm going to multiply these two out and get a quadratic. So my quadratic, when I multiply this out, is going to be x squared minus 5x plus 4. Now I can take these two quadratics, multiply them together, and get my standard form polynomial. So let's do this out in an organized way. So everything in the first times everything in the second. So x squared times x squared is going to give me x to the 4th. X squared times negative 5x is going to give me negative 5x cubed. X squared times 4x is going to give me 4x squared. So I'm done with this x squared. I'm going to move along to 4x. 4x times x squared is going to give me 4x cubed. 4x times negative 5x is going to give me negative 20x squared. 4x times 4 is going to give me 16x. So I'm all set now with the 4x, and I'm going to move along to the 4. 4 times x squared is 4x squared. 4 times negative 5x is going to give me negative 20x. And 4 times 4 is going to give me 16. So notice how I've written these so you can see from highest degree to lowest degree, and I can nicely add these up. So our standard form polynomial is going to be f of x equals x to the 4th minus x cubed minus 12x squared minus 4x plus 16. Let's take a look at the end behavior for this polynomial. So my highest power is 4, and my leading coefficient is 1, and this is positive. So I know my end behavior is going to rise on the left and rise on the right. Let's now find the y-intercept. Our y-intercept is going to be our c value, specifically 16, or again, I can take the zeros now and multiply those together. On the last problem, we multiplied the factors, and now we're going to do negative 2 times negative 2 times 1 times 4 to get our y-intercept as 16. Let's now sketch the graph using all of our key information. We have our x-intercepts, we have our standard form, we have our end behavior, and we have our y-intercept. This is enough to now go to our sketch. So let's start to map all of this out. We have a y-intercept of 16, so we're going to plot that. We have zeros at negative 2. We have zeros at 1 and at 4. Our end behavior is going to look something like this. And now we can start to graph. And again, we're going to go from left to right. So that's how you want to think about this, and that's how you want to build it. So I'm going to start here. And before I do this, I should probably think to myself, when am I going to touch the graph and when am I going to cross the graph? I need to have some sort of plan. So I look at negative 2, and negative 2 has a multiplicity of 2. So when I have an even multiplicity, this is going to touch the graph at negative 2. Or, sorry, touch the x-axis at negative 2. And for 1 and for 4, I'm going to cross the x-axis at 1 and 4. So let's start to do this. Negative 2, I'm going to start up here, and I'm going to touch the graph and bounce right back up. So I'm coming down, I touch at my x-intercept, and I come right back up. So my next point of interest is my y-intercept, which is 16. So I'm starting to come down to 1, which is my next 0, and at 1, I'm going to cross the graph. And I'm coming back up because at 4, I'm again going to cross the graph. So this is my sketch of this polynomial given these zeros and in standard form. We want to think about what this looks like on our graphing calculator and help us confirm what we've already sketched. So when we use our graphing calculator, this is our visual, and it does look the same as what we just sketched. The essential questions for today's lesson: how are the factors, zeros, and x-intercepts of a polynomial related? What does the degree of a polynomial tell you about the graph of a polynomial? Think about these questions tonight, and we're going to discuss these as we explore polynomials in more depth tomorrow. Yeah. After watching today's video on graphing polynomials, try these. For 1 and 2, write the following polynomials in standard form. For 3 and 4, determine the end behavior and the y-intercept of the following. And for 5 and 6, identify the x-intercepts and sketch the following graphs. Thanks for joining me in Core Concepts to Algebra 2. See you next time.